Good day everyone! Today we are going to learn how to code a binary logistic regression in Python. To start, we need to install first the required library, which is scikit-learn. Then we need to import the necessary library, which is from scikit-learn.linear_model. Import logistic regression. This is used for implementing logistic regression models. Next, we input our dataset. This list represents the weather. X represents the features or independent variables. In this case, it's the temperature and humidity respectively. An example we have here first in the list is a weather with a temperature of 20 and humidity of 70. On the other hand, Y represents the variable being predicted, rainy or not rainy.
Now, we create a logistic regression model. This is used for predicting the outcome of a categorical dependent variable based on one or more predictor variables. We then train the model using the fit method. We're essentially teaching the computer how to make predictions based on the provided data. Predict whether the weather is rainy or not. Let's predict a weather that has a temperature of 28 and humidity of 50. We then use our trained model to predict whether it's going to rain or not. Lastly, we're going to print the prediction. If the weather is rainy, it is represented by 1, and if not, 0.
Next, we'll delve into coding multinomial regression in Python. Similar to binary logistic regression, we begin by importing the necessary library, logistic regression, from scikit-learn, as this is used for implementing logistic regression models. Next, we are also going to input our database just like in the previous example. This list represents the weather. X represents the temperature and humidity. These features help us understand and predict the type of weather. On the other hand, Y represents the variable being predicted, which is the type of weather itself. For instance, it could be categorized as sunny, rainy, or cloudy based on the given temperature and humidity values.
Next, we create an instance of the logistic regression class. Specifying multi_class is assigned to multinomial to indicate that we are dealing with a problem where the target variable can have 3 or more possible outcomes. The solver assigned to LBFGS is an optimization algorithm that works well for smaller datasets. We then fit the model to our dataset using the fit method. Finally, we use a trained model to predict the weather type for a new observation with a temperature of 21 and humidity of 80. The predict method returns an array of predictions and we print the first element of this array to get the predicted weather type.
Lastly, we will be teaching you how to code an ordinal logistic regression in Python. First, we need to install the required library, which is mord. We can do this by running pip3 install mord in the terminal, and if you are a Windows user, write pip install mord. The mord library provides tools and models specifically tailored for handling ordinal regression tasks. It offers implementations of ordinal regression algorithms, including different methods for fitting ordinal regression models and evaluating their performance. Now, we import our necessary libraries. By importing logistic IT, you can create instances of this class and use its methods to perform ordinal regression using logistic regression with the irrespective of dice approach. The label encoder class from the sklearn.preprocessing module in scikit-learn is used to convert categorical labels into numerical labels. Lastly, NumPy is a powerful library for numerical computing in Python. It provides support for large multidimensional arrays, along with a collection of mathematical functions to operate on these arrays efficiently. Next, we are going to input our dataset. Similarly, X represents the temperature and humidity, while Y represents the severity of the weather. In this case, mild, moderate, and severe because, as mentioned, ordinal logistic regression is used when the outcome you are trying to predict is ordinal, meaning it has ordered categories. Now, we convert the target variable or the dependent variable, which is the y, to integers using label encoder. This is necessary because logistic IT expects integer labels representing the ordinal severity levels. Then, we create an instance of the logistic IT class. This instance serves as the foundation for training and making predictions in our ordinal regression analysis. We then train our model using the fit method. To predict the weather severity of a temperature of 17 and a humidity of 70, we use np.array as this ensures that the new weather data is correctly formatted as a NumPy array, which is expected by the predict method of the logistic IT model. Then, we use our trained ordinal regression model to predict the severity of the new weather condition. Lastly, by running this code, we have an outcome of 0, which is mild.